Hello everyone. In this video I will show you how to use the PinkZ2 board as a regular FPGA board completely without using Python. Usually Pink is used in projects with Python and Jupyter Notebook to quickly build complex projects from digital signal processing to artificial intelligence. But today we will learn to use it the classic way, as a regular FPGA board to study the hardware description language, VHDL, and digital logic. I will show you everything step by step from installing Vivado to uploading a test project to the board and lighting up an LED. Well done, let's get started. So, what will we need? First, we will download and install Vivado Design Suite. Second, we will create and set up a test project in VHDL. Next, we will perform synthesis, placement, and routing, implementation, and flashing the board. In the end, we will check that everything works and our LED really lights up. Installing Vivado. Let me say right away, you can find all the links in the description of the video. So, you need to go to the official Vivado Design Suite download page. We will be using the free version. For this, you will need to register. At the time of recording, version 2025.1 is available. In principle, the instructions should also apply to later versions. I think you will manage just fine. We need to download Vivado Edition. Choose the unified installer for your operating system. In my case, it's Windows, so I choose this version. After that, you will be asked to register or log in to the system. The registration form is simple. Fill the fields and click download. Once the file is downloaded, just run it. Now let's proceed to installing the program itself. You will also be asked to log in again. We enter our data. I recommend selecting the Download and Install Now option to avoid possible errors with separate downloading. Click the Next button. Here we select the Vivado product and click Next again. Then select the free version, Vivado ML Standard, since we are using the program for personal and educational purposes. And again click Next. A component selection menu for installation will open. From the whole list we only need Vivado. You can uncheck Vitus Model Composer and Dock Now. We don't need to purchase a license, so we also uncheck the last option. Now we need to choose the required devices. Our chip is in the Zynq 7000 system on chip section. That is exactly the one we select. That's all we need. Click Next. After that, you will be asked to agree to the license agreement. We agree and click Next. All that's left is to choose the installation path and, if necessary, adjust additional settings. Click the Install button. The process of downloading and installing components will begin. This may take a long time. In my case, the installation took an hour and a half, so be patient. Now we can move on to the next step, creating and setting up the test project. Creating and setting up a test project. So I just launched the Vivado program. This window will open where I will click the Create Project button. Click Next. Choose the project name and its location. I will name the project Test. In the next window we select RTL project and click Next. We will be asked to add the project source files. Here you can immediately add the project file, which can be downloaded from the GitHub repository. I always recommend copying the source files into the project folder. And this can be done by checking the box Copy Source Files into Project. Next, we are asked to select a constraint file, which you can also find in the GitHub repository. There are two versions there. I choose the modified version, which I slightly change for our needs. It contains the essential minimum and a short instruction on how to work with this file. And I also strongly recommend copying the constraint file into the project by clicking the corresponding checkbox. This way, if you change this file inside your project, then the changes in it will not affect the main file. Click Next. Now we need to add our board files to the project. Here's how you can do it. Go to the Boards tab. Here we can see that at the moment our board is missing. All we need to do is again copy the board files folder from the GitHub repository into the Vivado program folder at this address. I will also write it in the video description. You just need to copy these files. And then return to the project setup and click the refresh button. Next, in the search field, we enter ping, and among the boards we see ping Z2. Clicking on it, in older versions you can already continue working with this project. The newer versions, the program downloads the necessary files from the repository. You just click the download icon. After that, the board will be added, and the program will know what board it is. Click the Next button. Now click Finish and our project is created. Please don't be scared, there are so many different windows, buttons and names here. But in fact, everything is made very convenient and simple. Our time will figure it out. Right now it's not so important. Let's pay attention to this window. Here is our test file that we added. In fact, it is very simple. It is very important that our entity has the same name as the file itself. Next, what do we see here? We have one input and one output. The input is a switch and the output is an LED. What are we doing here? Simply our output, the LED, takes the value from the switch. If the switch is equal to 1, the LED will light up. If the switch is 0, the LED will turn off. That's all for the code of our file. The next important step is to set up the constraint file. That is, we literally need to connect our input and output ports, meaning the switch and LED, to specific pins on the board. So look. Here we have a pinout of our board. And we just need to connect the switch with what we have written in the code. That is, we need to take pin M20 and connect it to the input switch. And connect LED pin R14 to the output LED that we used in the code. For this, we open the constraint file, which we also added to the project. It looks like this. Look, here are the switches. Here it says which pin corresponds to the pin out. See, here is M20. And here we also see that it is pin M20. It needs to be connected to the port that we used in the code. For this, we uncomment this line. And now instead of port name, we need to write the name of our port. In our case, it is input switch. Just copy this and paste it instead of port name. Now we need to find our LED. Here we also have LEDs. We see that this is pin R14. In the constraint file, this is also pin R14. We also uncomment this line. And instead of port name, we need to write the name of our port. This is output LED. All done. Now we can move on to the next step. Synthesis, implementation, and flashing the board. We just press the green play button and thus we start the synthesis of our code. There is no need to change anything here, just press OK. In this window we can observe that synthesis is happening now. Great! Synthesis was successfully completed. Now we can start implementation. This option is already selected here, so we can just press OK. Also in this window we see that implementation is in progress now. A message appears that implementation was successfully completed. Now we are offered to open the implementation design. But we will not do this. We will just run the bitstream to later upload the firmware to the board. Just press OK. Great, this process was successfully completed. After that, I suggest you open Hardware Manager to upload the firmware to the board. At the moment we don't have a device here. It needs to be connected to the computer via a USB cable and switch the switch to the on position. Then you click here Open Target and the Auto Connect button. Thus the program will automatically find the device and connect it. Here you can see that our board is connected. It says here that it has not yet been programmed. What we need to do is just press the Program Device button. No need to change anything. Once again, just press the Program button. Great, the status has changed to Programmed. And now we can see the functionality of our code on the board. In the end, let's check that everything works. You can see on the board that the Done LED lights up. This means that the firmware is loaded and we can test the board. I will simply switch the switch 0 from position 0 to position 1. At the same time our LED should light up. Well then, let's try. Great, the LED lights up. In this video we learned how to use the PingZ2 board as a regular FPGA board without using Python. This approach is perfect for learning VHDL and digital logic. You can find all files and instructions in my GitHub repository. Links will be in the description. I will be very happy with your subscriptions. If this video was useful for you, please give it a like. I wish you success in your projects.